Alright, now we're going to do the third problem from the fourth contest of ACSL in 2014 and 2015. The problem is a data structures problem using binary search trees looking for the positive difference between the internal path lengths of the trees made by Walt Disney and Disney World. So what we have to do first is create binary search trees for each of those two strings. I always write out the alphabet so it's easier to compare different characters. Our first node is the first letter in the string Walt Disney, which is a W. From there, A is less than W, so it goes to the left of W. Now we look at L. L is less than W, so it's going to the left of W, but it's greater than A, so it goes to the right of A. T is less than W, so left of W, but it's greater than A, so right of A, and greater than L, so the right of L. Then D is less than W, greater than A, but less than L, so to the left of L. Then comes I, which is less than W, but greater than A, less than L, but greater than D, so it goes to the right of D. Then comes S, which is less than W, greater than A, greater than L, but less than T, so it goes to the left of T. Then comes N, which is again less than W, greater than A, greater than L, less than T, less than S, so it goes to the left of S. Then comes E, which is left of W, greater than A, less than L, greater than D, but less than I. And then finally Y, which is the only one that's greater than W. Now we're looking for the internal path length, which is, remember, the depth of each node multiplied by how many nodes are at that level. So I draw lines to separate the levels of my nodes so you don't get confused. The levels of the nodes, again, start from 0, so I always start by writing to the right, inside each line, the depth of each node. To the right of that, I'm going to write how many nodes are in each level, and be sure to multiply those out, and then we're going to add them to get our internal path length. So we have 0 plus 2 plus 2 plus 6 plus 8 plus 10. And the sum of that is going to be our internal path length. So the internal path length for the string Walt Disney is 28. Now we're going to go on and make the binary search tree for the string Disney World, and then we're going to find the positive difference between the two internal path lengths. So I'm going to go to the next screen so we have room to make our tree. Alright, again, I always start with the alphabet so it's easier to compare the characters in each string. So we're looking for the binary search tree for Disney World, which always starts with the first character of the string, so that's a D. Next comes I, which is greater than D, so to the right of I. Then comes S, which is also greater than D and also greater than I, so to the right of I. Then comes N, which is greater than D, greater than I, but less than S, so to the left of S. After that is E, which is greater than D, but less than I, so to the left of I. Then comes Y, which is greater than D, greater than I, and greater than S, so to the right of S. Then comes W, which is greater than D, greater than I, greater than S, but less than Y, so to the right of Y. Then comes O, which is greater than D, greater than I, less than S, but greater than N, so it goes to the right of N. Then comes R, which is greater than O, so to the right of O. Then comes L, which is to the left of N, so that branch over there. And then finally D, which is equal to D, so to the left is less than or equal to, so that goes to the left of the root node. Now again, we're going to divide up our tree by levels as we did with the first string and find the internal path length. So starting from 0, I'm going to label each level, and again we have 4 different levels, and then multiply that by the number of nodes at each level. And then once you sum that all up, you're going to get the internal path length of the string Disney World. So the internal path length is equal to 0 plus 2 plus 4 plus 6 plus 12 plus 5. and that number is equal to 29. So now looking back at the question, we need to find the positive difference between the internal path length of this string and the other one, which of course 29 minus 28 is 1. So 1 is going to be your final answer.